If statements. Almost as fundamental to programming as the function, if statements let us make our programs smarter. They let code do different things based on a conditional expression. In this chapter, we go into the many ways that if statements can be used to control the flow of the program. We see not only if statements, but also the similar elif and else statements, which can only be used in conjunction with if statements. Since these statements all have bodies, and are compatible with functions, we spend a lot of time talking about how they can be combined together in different ways. The chapter also introduces a sophisticated nuance of conditionals called Truthiness, which lets us use any type, not just Booleans, as if they were Boolean values. Finally, the chapter also touches briefly on the related, advanced concept of event handling, specifically in Designer, and how it relates to the idea of if statements. The first section of the chapter is all about the syntax and usage of if statements. The two essential parts are the conditional, which is the expression after the if keyword, and the body. The conditional expression is meant to be a question that determines whether the body will be executed, or skipped. The body of an if statement is very similar to the body of a function, except they do not have their own scope, they use the same scope as the enclosing body. An if statement can also have an else statement afterwards, which has its own body. Should the conditional of an if statement evaluate to false, then the else body will be executed instead. A key insight of the if statement is that it lets us skip over some lines, depending on the values of the variables at that step. We call this behavior branching execution, and it makes tracing the program much more complex. The second section of the chapter is about a curious idea called truthiness. Conceptually, the conditional of an if statement is supposed to be a Boolean value, like the result of using the equality operator or greater than operators. However, in Python, and many other modern languages, you can use any type of value in a conditional. When you do, Python applies the rules of truthiness to determine if the value should be treated as true or false. Most values are considered true, with the exception of the empty string, the integer 0, the float 0.0, and the special value none. All other values will be considered true, allowing us to write convenient shorthand when we want to test if a variable or expression is not one of those values. Note that the value does not actually change to become true or false, this is merely about what Python considers in its mind. This section covers how if statements can be combined together with functions and even other if statements to make much more complex programs. The indentation rules for the bodies of these statements are consistent, but can still be tricky to follow. The control flow is also a little bit tricky, since suddenly you can have more than one return statement inside of a function, because lines are able to be skipped based on different conditions. This section also introduces the elif statement, which can appear any number of times after an if statement, but must always be before the else statement, if there is one. The elif statement allows you to specify bodies that should be executed when the if statement, and any previous elif statements, are skipped. Only one if/elif/else body will be executed in a chain. The section also covers some ways that if statements are misused, such as in functions that return Boolean values, or when programmers unnecessarily test for the equality of a Boolean value. To help see the different ways that if statements can be used, the penultimate section covers a list of logical patterns that provide templates of code to you, the programmer. The idea for each pattern is to fill in the blanks of the template, modifying the structure as needed. There are 6 patterns covered in this section. They can be somewhat narrow in their use, and are more like guidelines than strict suggestions, but should help give more examples of how code can be structured. The final section goes into a somewhat specialized topic of event handling in Designer. We have previously used Designer to generate simple graphics by calling functions. However, event handling allows us to make more sophisticated programs that have user input by binding functions to events using the when function of Designer. When these events occur, like clicking the mouse or typing on the keyboard, the bound function will be executed. In this way, the when function ends up being a little similar to the if statement. However, the when function is a lot less flexible and meant strictly for event binding in Designer, and has no existence or purpose outside of that.